Greetings and welcome, friends. Today we are in section 3.3 of our Big Ideas book. We are talking about function notation. Function notation. We already know what functions are. Functions are a relationship between two values, two variables, and they have a very specific relationship in which there's exactly one output for every input. We've learned about the idea of linear functions that can be written in the form y equals mx plus b, but function notation, the word notation just means the way you write something, okay? The way you would note it, perhaps, all right? And so by naming a linear function f, we can give it a different name. We can use function notation, and instead of writing y equals mx plus b, we can write this right there, which I want to point out is read as f of x. F of x. That does not mean f times x, which is what we've had previously with parentheses and something out in front of it. We've interpreted that as multiplication. So this is read as f of x. So the function's value, or maybe let me say it this way, the value of the function when x is plugged into it is kind of the way you'll think about it. So the notation f of x is another name for y. Notice the only thing that changed between these was y is now written as f of x because they are the same thing. F of x represents the output, Amity, right? It is the output of the function, just like y was the output of the function. It's just a different way of naming it. It's a little more formal, if you will. And so if f is a function and x is in its domain, then f of x represents the output whenever you plug in an x value. And you can use other names for functions. You could have function f or g or h, or function w of x is... Yeah, you can use letters. That's what it's saying. Oh, they were just giving you some examples, but the common ones are F, G, and H. Right? So you're writing this down. Example 1. Evaluating a function. So here we go. It says the following. Evaluate f of x equals negative 4x plus 7 when x equals 2. So that means if x equals 2, I'm plugging 2 in for the function's x, and very specifically the x part, not the f of x, just the x part. So I would write this as, I would say f of 2 equals. So instead of y equals, I'm saying f of 2. The value of function f when I plug 2 in can be found by doing negative 4 times 2 plus 7. So here we go. F of 2, now I'm just going to PEMDAS evaluate this, okay? So negative 4 times 2 is negative 8, and negative 8 plus 7 is negative 1. So that means f of 2 is equal to negative 1. So the input was the 2, and the output was negative 1. You could think of this as the ordered pair 2, comma, negative 1. Right? So, if I want to figure out what about when x equals negative 2, I'm going to say, what is f of negative 2? All right, so that would be negative 4 times negative 2 plus 7. And negative 4 times negative 2 is equal to 8. 8 plus 7 is equal to 15. So f of negative 2 equals 15. I had a student that wanted to like divide both sides here by the negative 2, but like I said, this doesn't mean f times 2. F of negative 2 would have been the same as if I said y equals 15 or y equals negative 4 times, right, x plus 7. It's the same idea. So this is the name of something, and it represents the output. And so this is saying the output is 15 when the input was negative 2, right? I plugged in negative 2. Takes a little while to get used to. But we'll be doing plenty of these throughout the course. And that would have been the same as if I represented that as negative 2 comma 15. All right? So right, Amity, you getting this? Let's keep going here. All right, so let's try these ones. So, we even have a function g over here. So, if f of x is equal to 2x minus 5, I could find f of negative 4 by doing 2 times negative 4 minus 5. That's negative 8 minus 5. I would get f of negative 4 is equal to negative 13. So friends, so that's f of negative 4. If I want to figure out f of 0, which by the way, f0 is a wonderful Super Nintendo game, I would plug 0 in for x. So that means 2 times 0 minus 5. 2 times 0 is 0, 0 minus 5, I get negative 5. So when I plug in 0, right, 0 is plugged in for x, the output was negative 5. And we could do f of 3, but I'm interested in, I'll do one for function g over here. So let's do g of 3. So g of 3 means I would plug in 3 for x. Right, if I asked you, tell me what g of 3 is, that's shorthand notation for saying plug in 3 for function g's input. So that's the opposite of 3 minus 1. The opposite of 3 is negative 3. Negative 3 minus 1 is negative 4. You probably didn't have to write that step, but I did it for us nonetheless. Right, and g of 3 equals negative 4. Another way of writing that is as the point 3 comma negative 4. If you wanted to write that as an ordered pair representing an x and like a y, for instance. All right, this gets a little bit crazier, where now we have to really think about what these names mean. All right, what these names mean. Yeah, you can practice some more of those later if you need to. Okay, so this problem, I really love this problem because it forces us to think about what this stuff means. Okay, let f of t be the outside temperature, ladies and gentlemen. Let be the outside temperature in Fahrenheit t hours after 6 a.m. So the input is t, the number of hours after 6 a.m., and the output is going to be the outside temperature, is the output. And it says, explain the meaning of each statement. So the input here is 0. What does 0 mean as an input for this problem? How many hours after 6 a.m.? So 0 hours after 6 a.m. is what time in real life? Yeah, if t equals 0, that's the same as 6 a.m., right? Right, 0 hours after 6 a.m. is 6 a.m. And f of 0 When I plug in 0 for time, I'm getting the output is 58. So the meaning of this, all right, the output is 58. The meaning of this is that at 6 a.m., it was 58 degrees Fahrenheit. That's what that means. What that means. Okay. All right, for this next one. The input is 6. If t equals 6 was the input, what does that mean in real life? It's noon, right? Yeah, 6 hours after 6 a.m. is noon. Right? What I believe they call that 12 p.m. That's always the tricky one. That one always throws me off. All right. So at noon, they're saying the temperature was N. The output was N. So that means at noon, it was N degrees, and I don't know what N is, Fahrenheit. This next one is the best one. That it did, yeah. We lost it. Yeah. So guys, for this, notice this is comparing an output to an output, right? F of 3 and F of 9 are two separate outputs, okay? So F of 3 is talking about the temperature 3 hours after 6 a.m. What does t equals 3 mean in this problem? What time is that? 3 hours after 6 or 9 a.m., right? And what does an input of 9 mean? T equals 9 means 3 what? 3 p.m., right? Right, 9 hours after 6 a.m. is going to be 3 p.m. Did I do that right? Yeah. No, wait a minute. All right, got it right. Actually, it was super adorable. Little side Waddy story real quick. Since it's Griffin's birthday today, I was like, Griffin, like, how many fingers am I holding up? And he counts my hand, and I've got 4 fingers. You go, 1, 2, 3, 4. And I was like, yeah, you're 4 years old, right? And I was like, you show me 4 fingers. And he looks at his hands. He says, I have 5 fingers. I have 5 fingers. And then he looks at both hands. 10 fingers. I'm like, no, like, show me 4 fingers. And he's like, 5 fingers. And like, it was adorable. Like, he's like, I don't have 4 fingers. I have 5. And he's very adamant about it. So what this is saying is, right, F of 3 is referring to the temp at, right, 9 a.m. And they're saying that the temperature at 9 a.m. was less than the temperature at 3 p.m. Right? Don't worry, it's cool. So I would interpret this, if I wanted to put words to this, I would say it was colder at 9 a.m. compared to 3 p.m. Right? So this was like super shorthand information, and it gave me all of this information in very short, a short little space of text. Unless a cold front moves in. But in general, you're right. In general, yeah, in general, you're right. It's usually colder in the morning than it is the afternoon. Yeah, I like it. Okay, so yeah, maybe I'll have you guys practice some more like that one during the class quest today. Let's keep going, because this takes a while to get used to this idea, and that's okay. All right, for function h of x equals 2/3 x minus 5, find the value of x for which h of x is -7. So we're finding the value of x, the input, when the output was -7. Okay? So I'm not plugging -7 in for the little x. I'm going to plug in -7 for this, for the y, so to speak. I'm plugging -7 in for the output or the y, right? Or the entire h of x is -7. So I'm going to write -7 equals 2/3 x minus 5. Wow, this is a good algebra problem right here. To solve this, yeah, let's add 5 to both sides first. So I'll have -2 equals 2/3 x. And to deal with this 2/3, the easy way, multiply both sides. Yeah, dividing both sides by 2/3 works, but that's usually weird to divide by a fraction. It's easier to think about multiplying both sides by its reciprocal. Yeah, you could multiply both sides by 3 and then divide both sides by 2. You could do this in 2 steps. I'm showing you a combo, right? Where you're like going to be able to take this problem down in like one go. And check out what happens here. This 2 and this 2 conveniently cancel out. This 3 and that 3, this 2 cancel out. I'm going to have 3 times a negative. I'll have the following. -3 equals x. Or x equals -3. So that means that h of -3, if I input -3 in for function h, that I get -7 as the output, right? So input, right? Input was right here. Input was right here the whole time. We were trying to solve for the input, but we happen to know what the output was. The output was equal to -7. It's just a different way of writing it is all. That's all it is. All right, let's keep going. 2 more examples. Yeah, we're time traveling right now. So, all right, so guys, check this out. Let's make a table here. I'll have x and I'll have f of x as my output. And here's my work column. Don't worry about it. Is going to be, right, 2x plus 5 is what I'm going to end up doing for work. So guys, for inputs here, if I want to graph a function using a table, all I've got to do is pick some points, all right? And I want to pick some easy points. And I would say pick like roughly like 5 points maybe. 0 is a great point to pick. Maybe 1, maybe 2. And then let's get some negatives just to see what happens in that instance. All right, so I pick some points. I'm going to plug -2 in for x and figure out what f of x, the output, is. All right, so let's actually start with 0. 2 times 0 plus 5. 2 times 0 is 0. 0 plus 5 is 5. And let's plot that point. 0, 5 is right here. So this is my x-axis, and you could think of this as my f of x axis. That's the same as y, right? Y, in quotes. Same thing, same thing. Just a different way of writing it. Right? Let's see, 2 times 1, that was smooth, is 2. 2 plus 5 is 7. So when 1 was the input, 7 was the output. Let's do 2. 2 times 2 is 4, and 4 plus 5 is 9. So when 2 was the input, 9 was the output. And then we could try some negatives here if you want. 2 times -1 plus 5. 2 times -1 is -2. And 5 and -2 combine to be 3. So left one, -1 on the x-axis, gave me an output of +3. And you could probably guess, well, for one, they said this was linear. This was a function that was linear. It's of the form mx plus b. And notice it looks like this is a line, right? It looks like it's going, each of these were going up 2, right? Up 2, up 2, up 2. And graphically, you can see it's going up 2 and over 1. We'll be talking about that tomorrow. Or if there's a snow day, then we'll talk about it Wednesday. But if you were worried about not learning about that concept tomorrow because of snow, you can still catch my video online. Actually, you could just stay home, have some soup, and like hot cocoa, and just snuggle up and watch all of Waddy Math's videos. That would be amazing. Oh yeah, it's so hard because like you'll set your YouTube to autoplay and you'll be like, oh man, I just finished an episode of Waddy Math and now it's going to start the next one. I so should get off this couch. I've spent 8 hours sitting here watching math videos. I really should have done something else. Yeah, you could. You could. And then you'll be like texting your friends, did you see that? What happened at the end of that last Waddy Math episode? Yeah, oh man, that was such a cliffhanger. No, I don't know. Let's see, 2 times negative 2 plus 5 was negative 4 plus 5, that's 1. But also, I kind of could have predicted that because this is a line. And because it's a line, I should actually represent this linearly. So I plot some points, and then I use those points to predict the other ones. Yeah. Yeah, I'll use blue here. Correct. I 100% agree. I did. And there's video evidence of it. You're right. So this is a up 2 over 1 line. Here's a function. I could even think of inputs like 0.5 and find their corresponding output. Good stuff. Good stuff. All right. Last problem is about a helicopter. A helicopter, I believe, actually. But I'm on the internet, and I'm right. Let's see. The graph shows the number of miles a helicopter is away from its destination. Okay. After X hours on its first flight, as shown. So here's the first flight of the helicopter. Amazing. All right. So input of 1 hour. That means after 1 hour, it looks like it traveled 200 miles. Right? Is the way I would interpret that. Are you guys with me on that? 1 hour into the first flight, they were 200 miles traveled. Or 200 miles away, I think. Okay, it says, so this is from its destination. That's why it's getting less miles over time, because it's getting closer to its destination. So that's interesting. After X hours on its first flight. On its second flight, the helicopter travels 50 miles farther and increases its speed by 25 miles per hour. The function f of x equals 350 minus 125x represents the second flight. Which flight takes less time? All right, one of the ways we could do this is by graphing both of them on the same coordinate plane. Yeah. So let's make a table. So here's x, here's f of x. My work column is just going to be 350 minus 125x. Can this helicopter... no, I should only have between 0 and up, right? I can't have negative number of hours on the trip. So let's do like 0, 1, 2, and maybe 3 will be enough. So 330 50 is what it starts at, minus 125, plugging in 0 for x. That's just going to be 350. Let's plot that point. So 0, 350. Notice it's starting 50 miles further, right? Further than the first helicopter. All right, let's plug in 1. 350 minus 125 times 1. Man, 125 miles an hour. 350 minus 125 is going to be what, 225? All right, so that means at the point 1 over 1 up 225. Looks like it'd be halfway between those grid marks of 250 and 200. Ooh. Let's plug in 2. 350 minus 125 times 2. No. 125 times 2 is 250. Subtracting 250 from 350. Is it just a hundo? Yeah, so over 2. It's all right. It's all right. And let's see, lastly, this is going to be 350 minus 125 times 3. And 125 times 3 is 375. Yeah, it's going to be negative 25. That's weird. Yeah, that means it would have flown right darn past its destination. All right, so let's draw the line represented by this function. And I'll only draw it with a restricted range of positive. All right. What's your question? Amity, what is your question? Okay. The yellow line is the second flight. And the orange line was the first flight. So, which one takes less time? Is it? Which axis represents time? Yeah, the yellow one looks like it was done in like 2.9 something hours. The other one was done in 3 hours. So even though the yellow one started at 50 miles away further, it caught up right at this point. Yeah, it was traveling faster. That's right. That's right. What if I ask this question? Let's extend this problem slightly. What if I ask, this is a Mr. Waddy bonus follow-up, how long was the second flight? How long was the second flight? What? Well, it's whatever this amount is, but the second flight ends, Amity and Jimmy, be quiet. Ethan, let's think about this. The second flight ends when you are 0 miles away from your destination, right? So Jimmy, the second flight ends when the output, when f of x is equal to 0. Would you guys agree? If you're 0 miles from your destination, you're there. You are there, right? And if my original function was f of x equals 350 minus 125x, that means I could plug in 0 for not the input, but the output. Right? So instead of if I was asking the question, how far did I go after 1 hour, which is answered here, that would be plugging in 1 for the input. I'm plugging in 0 for the output. The distance is 0. And I want to figure out what was my input. All right, so 0 equals 350 minus 125x. How could I solve that? How do I solve that for x? I think I agree. I think I agree. So I'll get negative 350 equals negative 125x. I don't know what that's going to answer, but the inverse of multiplying by negative 125 is going to be dividing by... Yeah, sorry you guys are running out of space. I extended this question, didn't I? Yeah. So x is equal to... ding, 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 ding. I get 2.8. So that means the second flight arrived. It took 2.8 hours. All right. We're just considering when it landed. Yeah. All right, cool. Well, we're going to do some class quests. Thanks for watching, Internet friends. Have a great day.